Why is there a need for affordable spectrometers? In a world where advanced technology is often equated with exorbitant prices, the quest for accessible and cost-effective devices is more vital than ever. Enter the PySpectrometer, a practical solution to this predicament. The PySpectrometer is a Python-based optical spectrometer designed with the primary intention of measuring the wavelength of homemade dye lasers and facilitating fluorescent spectroscopy. This tool, with its modest price, is designed to be within everyone's reach. The hardware of the PySpectrometer is fairly simple, consisting of widely available components which require no intricate alignments or complicated construction. The real innovation lies in the software, meticulously developed to provide a user-friendly interface and accurate results. The PySpectrometer's resolution and accuracy hover around a couple of nanometers, which is quite impressive considering the affordability of its hardware. When compared to commercial components such as the Hamamatsu C12880 MA breakout boards, which cost upwards of $300 and offer a resolution of 15 nanometers, the PySpectrometer stands out as a cost-effective alternative. To set up the PySpectrometer, you will need a Raspberry Pi 4 and PiCamera. Begin by attaching the PiCam and enabling it with Raspi config. Next, install the dependencies using the following commands: sudo apt get install python 3 opencce, sudo apt get install python dev libatlas base dev, pip3 install scipy, and pip3 install pqtils. Following this, you can run the program with python 3 PySpectrometer v1 p. To calibrate the device, shine 2 lasers of known wavelength on a piece of card in front of the spectrometer. Click the 2 peaks on the graph and enter the corresponding wavelength in each of the boxes. Then hit Calibrate. For best results, ensure your wavelengths are quite far apart, ideally one at the red end and one at the blue end. In conclusion, the PySpectrometer is a cost-effective, user-friendly and accurate tool for measuring wavelengths and conducting fluorescent spectroscopy. It is a testament to the potential for high-quality, affordable technology in the field of science. It is not just a tool, but a stepping stone towards a future where advanced technology is accessible to everyone.